Wait, what do you define her?
Seeing all the things that are to see in Rome, eating delicious Italian food,
Pizza? Oh, that's on birthday.
among other things.
Birthday.
What?
Like, you're just gonna be going to like museums and stuff like
Sure, yes. All right. So, problems you want to go over from problem set 24.
It's like we're gonna do like a little things, like go out and get drinks.
that. I really.
We're gonna have 3-course Italian dinners every night. So we got Nutella and rolls and cold cuts and anyway. All right, an espresso. If you're interested, talk to me. Maybe later this week I'm gonna go around and give a pitch to all the classes. All right. Anyway, problems you want to go over from problem set 27. All right, we've got a figure to find the perimeter of.
That's staircase.
Yeah, the stairway to heaven. 8, 4, 4, 4, 12. All right, now the perimeter. How do we find the perimeter of a shape? These are all kilometers. What's the perimeter of a shape?
Go around it.
The distance around it. Okay, so what do we need to add up?
8 plus 4 plus 4 plus 4 plus 12.
That's it?
I mean, I think.
So we've got 12, we've got 8,
Yeah.
we've got 4, we've got 4, we've got 4. Is that the whole perimeter?
No, there's another 4.
No, there's only 3 4s.
I mean, because half of 8 is 4.
So what's the problem? What do we still need?
We need the height of all those.
Yeah, we need these. How can we figure that out?
8.
Right, we can't actually calculate the distance of each one of these, but because this is, we can think of it as 3 rectangles stacked on top of each other, we know that these 3 all add up to 8. The total height of these rectangles on the left is 8. Individually we know they all add up to 8. We don't need to know what they are individually. We just need to know that they add up to 8. So we've got 12 plus 12. A rectangle that has a chunk cut out of one of the corners, same as the whole big rectangle.
I'm gonna try that.
So if it's something like this, for example, if it were the whole rectangle, the perimeter would be this side, and the top and the bottom, right? That would be the perimeter. Okay, if we cut out that chunk, we've still got this side and this side. Those are the same. Now for this side, instead we have this measurement plus this measurement, which add up to the same thing.
So I could just.
And so this side we have this and this, but the two of those add up to the same thing also.
I could just fill it in and then just do 8
So you can think of it as 12 plus 12
plus 8
plus 8 plus 8, right? Where this won't work is when you have something that's kind of U-shaped. Then it won't work. Then the perimeter is actually longer. But when you have something where there's just a rectangular chunk cut out of one of the corners, the perimeter is the same as if it were the whole rectangle. Interestingly enough. Next one we gotta go over. What questions about that one?
Number 25. No, number 24.
24. All right. Making sure we do our order of operations here correctly and keep track of our negative signs. 24. They tell us a cubed minus parenthesis a minus b parenthesis plus pipe a plus b pipe. All right. What does a equal?
A equals -2.
And b equal variables. How am I going to rewrite it?
Minus
Oh.
or negative.
No.
Oh yeah.
First thing I'm going to. Yes.
-2. Parentheses 2.
Yes. Parenthesis -2 parenthesis cube. All right.
Yeah. Minus.
Yeah. Yeah. Bracket.
Parentheses. -3.
-2.
-2. Yeah. Parentheses minus 3. Bracket. plus, that's the height,
Yep.
yeah. The whole number,
To do what first?
parentheses,
Parentheses. So what do I do inside parentheses here?
-2 minus 3.
Which
and
gives us?
-2 plus 3. -2 minus 3 is -5.
-5. All right. And
-2 plus 3 is
1. Okay. What do I do after parentheses?
1.
Well, really, actually, to finish doing the parentheses with the pipes, we should also then take the absolute value. What's in there?
-8
-8.
minus bracket -5.
Yeah. Okay, now what do I do?
Multiplication.
All right.
So -8 plus 5.
Yeah.
So -5 plus, -8 plus 5 is -3 plus
Yeah.
1 is -2.
Yeah. There you go.
What?
-2 plus 3.
You said that the answer was.
Absolute value of the
Here
theory.
is just A minus B, A is -2, B is 3, it'd be -5.
Oh, I copied it wrong. I'm sorry.
You said the answer was positive.
Yeah. So here, the mistake that I made. Where did I make my mistake? So what do you find it?
It's minus -80.
What?
In the pipes, it's minus -80.
It's inside pipe should be what?
It's my A minus.
Yeah, it should be A minus B. Right. So there's the mistake. This is why you got to copy them correctly. So we should have -2 minus 3,
-5.
which is -5, and the pipes makes it
5.
5. Okay. So
So that's gonna be -3. It's just plus 5.
yeah, got to copy these problems correctly. Got to copy them correctly. Otherwise, you make a mistake just like I did. Lose some credit.
Oh wow.
All right, one more.
This is why school is evil. I wanna do number 26.
26.
Yeah.
All right. What's -2 cubed?
-8, -8.
-8. What's -2 squared?
4.
All right. So far we've got -8. We got -8 minus 4
-5.
minus 5 plus what's the cube root of -64? 4 times 4
16.
times 4.
64.
Okay. What did they ask us to find the cube root of though?
64.
No. Right. They asked us to find the cube root of -64. So it should be -4, right? Because -4 times -4 is positive 16 times -4 gives us -64, right? So anytime you have a cube root or a fifth root or seventh root of a negative number, your answer will be negative.
Mhm.
I'll never ask you for the square root or the fourth root or the sixth root of a negative number because you get an imaginary answer. Okay.
That's not button.
Yeah, -21. Back to tests. Let's go over a few questions from them. If you are at home, and I've marked it right on the PDF in Jupyter Grades because technology. Mr. O's moving into the 21st century and dragging Latin along with him.
Oh, you see.
All right. Let's see these back. These were okay. I'll give you the average in just a minute. The average seems to be slipping a little bit, which is not surprising, but it is something that we don't want to continue. All right. For you. For you. For you. For you. The class average on this test was. See, it was more fun last year because I had a really large class, and so I could give like a mean, median, and mode without getting too much information about any individual student's grades. The average was a C+. So not great, not terrible, but we've had a sort of, this is what I generally, or this is what I saw last year also, is that as the year goes on, things start to slowly slide. So if you are in this position where you are slowly sliding, we need to be making sure that you don't continue to fall behind. The beginning of the year, most of this stuff you should have known already. As we continue to do new material, you need to make sure you master that also, so you can avoid the mistake in the future. And then, if you still aren't sure, ask me, or find some outside time to go over these things. We want to make sure we master the earlier material, because as we've seen with these additive inverses and multiplicative inverses, how we continue to build on these and further things. Yes?
If you get negative 2 times,
Yes, you lose 2 points on a problem, or 3 or 4, you can what's it called? Do correct of any, I don't think. Those 4, 9, 10, 11, 12, well actually 8, 9, 10, 11, 12, they ask you for.
What is the multiplicative inverse of -7?
Right, they ask you for the multiplicative inverse of these two numbers, of -7 and of 1/7. What's another word for multiplicative inverse?
The opposite.
No. We've got a multiplicative inverse.
And the additive.
And we've got our additive inverse. These are not the same. What's the other name for the additive inverse?
what?
What's the other name for the additive? What does this mean when we talk about the inverse of a number?
Tens.
The inverse of a number. Can anyone give me an example of some place you might use the inverse of a number? Or something where we see the inverse of a number? What about -1?
It's a big one.
When we talk about the inverse of a number, I recommend you take some notes on this because apparently we've got some gaps here. When we talk about the inverse of a number, we're always talking about one number and its inverse. We're talking about two numbers. The inverse is this relationship between the two numbers. Each number has an inverse of various kinds. The inverse is what we can use to undo the operation in question. So when we're talking about the additive inverse, we're talking about the number that will let us undo what operation? It's the additive inverse. What operation are we trying to undo?
Additive.
Addition. Great. So if, for example, the additive inverse of +5 is -5, because adding +5 undoes adding -5 and vice versa. If you add both of these numbers to something, they undo each other. They cancel each other out because they are each other's additive inverses. Multiplicative inverse.
Oh.
So for like multiplication, like if the number was like 5, like
Oh no, we'll get to multiplicative inverse. Let's just stick to additive inverse.
Positive 2.
Yes, positive 2/3. To find the additive inverse or the opposite of a number, we just flip the sign on it. If it's negative, it becomes positive. If it's positive, it becomes negative. What number is its own additive inverse? What number will not change? 0. 0 doesn't really have a sign. Adding 0 doesn't change anything. 100 plus 0 is 100. 17 plus 0 is 17. 0 doesn't do anything in terms of addition. It's its own additive inverse. But for any other number, we just flip the sign on it. If it's negative, we make it positive. If it's positive, we make it negative. Because if we add both of those numbers to something else, that original thing will stay the same. No matter how much money you have, if I give you $5 and then take $5 back, you still have as much as you started with. I undid the adding of $5 to your wealth. The additive inverse or the opposite. This is different from the multiplicative inverse or the, what's the other name for the multiplicative inverse?
Opposite.
No,
Multiplicative. Division.
no. All right, let me ask this differently. If I'm multiplying something by 5, what can I do to undo that? Divide by 5 or multiply by,
negative.
no. 2 times 5 is 10. If I multiply that by -5, I'm going to get -50. That doesn't bring me back to 2.
0.
No.
Oh, bring it back to 5.
Oh, bring 1.
No. What?
Oh, 5 over 1. Or 1 over 5.
1 over 5.
What do you think?
Why does that work?
Because it just takes you back.
Right, so if we've got 10 times 5, what's 10 times 5? 50. What if we then multiply by 1 over 5? No. 10 times 5 times 1 over 5.
Oh, 5.
10 times 5
Under
times
10, you get 10.
50, that's
It's 50
a
over
lot.
5.
That's 250, I think.
It's 10.
Okay, we need some review of fractions.
I said that.
Oh, but I know. Okay.
Oh, okay. Okay, yeah, I guess. Oops.
We don't like division in this class. So when we talk about the multiplicative inverse, we don't want to say that the inverse of multiply times 5, that's 50. How do we get back to 10? What can we multiply by to get back to 10? We could say divide by 5. What's another way to say divide by 5? Times 1/5. Because remember, 50 times 1/5, 50 over 1 times 1 over 5. Divide these both by 5. 10 times 1 is 10 over 1, which is 10. What's the other name for the multiplicative inverse? No. Thank you. Reciprocal. Reciprocal. Multiplying by 5 and multiplying by 1/5, if I do both of those to some number, what do I end up with? If I multiply some number by 5 and then by 1/5, what do I end up with? No. If I take some mystery number, I multiply it by 5, and then I multiply it by 1/5, what do I end up with? Don't say 1. We're going to end up with the original mystery number. Any number times 5 times 1/5 gets us back at that original number. Let's see why. Okay, x over 1 times 5 over 1 times 1 over 5. Right, we're multiplying with fractions, so we make these guys just fractions over 1. X times 5 times 1 is 5x. 1 times 1 is 5. Oh look, they cancel each other out. The multiplicative inverse or the reciprocal undoes multiplication by its reciprocal. How do we find the multiplicative? What about for 3/4?
Oh.
Right, 4/3. To find the reciprocal or the multiplicative inverse, we take the fraction. If it's not written as a fraction already, then we write it as a fraction, and we flip it. So to go from 17, for example, and find its reciprocal, first we'll rewrite it as 17 over 1, and then to find the reciprocal, we just flip it, and we get what? 1 over 17. So in this problem on the test, the first one they ask you for is what's the reciprocal of -7?
-7.
Right, so we write it as a fraction, -7 over 1, and then we flip it. So 1 over -7, or you could have written, yes.
Wait, but on the last one, I got something wrong. Like 2 points, and I corrected
A different color writing substance, or on a separate piece of paper.
it. I'm thinking,
That's fine. To find the multiplicative inverse, we flip. So -7, -1/7 is the reciprocal. If a number is negative to begin with, when we take the multiplicative inverse, it's going to stay negative. So the other one that they have, 1/7, what's the multiplicative inverse of 1/7? B. 1/7 becomes what? 7. We flip it, it becomes 7 over 1, or written more simply, just 7. You have to keep these two straight. They're not the same by any means. Yep. See why. Or fix it if it was a mistake. All right, let's see. Other ones that I wanted to talk about here. Number 15, what's the answer to number 15?
Number 15,
Yep, 15, what's the answer?
15,
The answer is what? Say it again?
15, X equals 15.
No, on the test.
Oh, I'm looking at the wrong.
Yeah, it's indeterminate. You should have ended up with 0 over 0, which you should write as. Yeah. All right. Any ones that you want to ask about quickly? Otherwise, we'll spend a few minutes doing some review for tomorrow's test.
Yeah, I mean, I don't think I can do that.
Which one?
I think number 3.
Number 3? Number 3 is just a unit conversion. Going from kilometers to centimeters. So you got to go kilometers to meters. There's 1,000 meters in a kilometer. And then you got to go from meters to centimeters, 100 centimeters in 1 meter. All right. All right, some quick review. Flip back to page 72. We've got more complicated equations to deal with, where we got multiple layers of symbols of inclusion and replacing variables. Here with these ones, you're going to have to be extra careful to keep track of your brackets and parentheses and all that. 17 on page 74, we introduced this term coefficient, where coefficient is one of the factors in something like 4xy. Usually when we talk about coefficient, we'll mean the numerical coefficient, which is the part that isn't a letter. So 4xy, usually if I say the coefficient, that means 4. We talked about algebraic terms being a single variable constant, the indicated product or quotient of some variables or constants, or the indicated product quotient of other expressions. Terms are things that we combine together using addition and subtraction. Things that are combined together with multiplication or division are parts of the same term. Distributive property, as you see there, we can do either one of these, A times B plus C, or AB plus AC. Both of those are equal to each other. So if we distribute out, we multiply A times AC, and then we add those two together. We can do the addition first or the multiplication first, as long as, and I saw some guys make some errors on this, as long as if you do the multiplication first, you have to make sure you multiply both terms by that, not just the first one. So if we multiply by A, we distribute that out, we get 8. All right, in 18, so I guess I should have started with 17 because 16 is already in the losses. 18, like terms have the same variables in the same places to the same powers. By same place, I mean same place, top or bottom of a fraction. It doesn't matter the order of them if they're all being multiplied together. XMP, PMX, MXP are all the same. Like terms, we can add together because they're the same sort of thing. It's like apples and apples. We can't together, we see on towards the bottom of page 79, 4XMP minus 2PMX plus 6MP. Whatever this thing is, XM, you can just add or subtract, respectively, the numerical coefficients of each term. In 19, on page 82, we talked about exponents. The exponent tells us how many copies of the number we're multiplying together. The base is the number that we're taking multiple copies of, and the exponent is the number that tells us how many to multiply together. We also say the power, x to the 4th power. When we take powers of negative numbers, things will change a bit. It depends on whether we're raising it to an odd or an even power. If we're taking a negative number and raising it to an even power, our answer will be positive, because that means that we have an even number of negative numbers that we're multiplying together. So those negatives will all cancel out, and we end up with something positive. If you're taking a negative number and you're raising it to an odd power, that means we have an odd number of negative numbers we're multiplying together, and the whole thing will be negative. Roots are the opposite of powers. Square root when we don't have any number there. We're asking what number, 2 copies of it multiplied together gets us the number inside. Third root, we're asking what. You're never going to be asked for an even root of a negative number, a second root, a square root, or a fourth root or sixth root. Because that doesn't, there's no real answer. There's no real answer for the square root of -9. Because 3 squared is +9, and -3 squared is also +9. This is an imaginary answer. So I won't ask you for those, but if it's a cube root, for example, the cube root of -27, there is a real number that we can multiply 3 copies of together to get -27. It's -3. Because -3 times -3 times -3, 3 times 3 times 3 is 27. When we have 3 negatives multiplied together, we end up with a negative number. Okay, so that does work.
Yeah, I would-
Yep.
Like, if I'm hearing what the question is, like, if you have 11,000,
Yep.
like, can you just like cross out like how many like if it's like 9 negative and 6 positive, they use maybe like 3 negatives and then they're like 3 negatives and
No, what you should do instead is ignore the number of positive numbers. With those problems that say if you multiply together so and so many negative numbers and so and so many positive numbers will be positive or negative, just ignore the positive numbers. It doesn't matter how many times you multiply something by a positive number, it's never going to change the sign. If you start with a positive number, you multiply by another positive, it stays positive. If you start with a negative multiplied by a positive number, it stays negative.
so if you had 10 positive and 3 negative,
Just ignore the 10 positives.
wait, so that it goes
Yes, it would be negative because those 3 negatives, 2 of them, the negatives cancel out, and then there's 1 more negative left over. And at that point, everything else is positive, and negative times a positive any number of times is going to stay negative. So for those problems, just ignore the number of positives. Only count the number of negatives. All right. Let's see. We can raise our variables to powers. Please make sure that you pay attention to where your negative signs go. So if you don't put parentheses around the value of a negative variable, so say we have, x cubed, and we say that x is equal to -2, we should rewrite, actually, I should say maybe -2 to the 4th. Gives us +16. If the negative sign is outside of that, first we do the exponent, 2 to the 4th is 16, and then we take the negative of that. So make sure that when you're plugging in these variables, the values of the variables, that you use parentheses and follow your order of operations accordingly. Page 86, volume. What's the general formula for the volume of any right solid?
Base times height times length.
No, that'll work if you have a rectangular prism, but what if you have a cylinder or a triangular prism?
base times, because, yeah, it's like the.
Normally they'll give it to you.
Oh, perimeter of the base times.
No.
No, it's 2AB plus. That's surface area. Oh yeah, that's right. I did a.
Look in the book.
Did a smooth brain proof.
Yeah, let's make sure we have these 2 formulas straight. Last year I had guys messing these up all year long. Don't be that guy.
Wait, I have a question.
It's
In the back of the book, it's like, it says S times.
For a cube.
Oh, wait, what is that? What is
S cubed side. So for a cube, the length of an edge is the same on all sides. All those edges are the same length if it's a cube. So length times width times height, those are all the same. Yep.
Area of the base times.
Yes, volume is area of the base times height. Whatever shape the base is, and how do we tell which side is our base?
The one that's not right.
The one that's not a rectangle, if there is one. We find the area of that, and then we multiply it by the height. Find the area of it. It could be a trapezoid, it could be a parallelogram, it could be a triangle, it could be a circle, it could be one of these weird funky things that Saxon loves to give you. We find the area of the base, we multiply it by the height. For a surface area, on the other hand, what's the formula?
2 times area of the base plus perimeter of the base times height.
Yes, 2 times area of the base plus perimeter of the base times height. These two formulas will get you the surface area and the volume of any right solid. For the volume, you only need the area of the base and the height. For the surface area, in addition to the area of the base and the height, you also need the perimeter of the base. When we get a volume, what kind of units will the volume of a solid be given in? What kind of units? Nope. Volume. Cubic units. Cubic units. Square units are flat. They don't take up any space. You could stack 24 square feet on top of each other and they wouldn't take up any height. Because they're only square feet. They only have area, length, and width. They don't have any height. Cubic feet, if we're talking about something three-dimensional, oh look, three-dimensional to the third power, that's not a coincidence. We're talking about things that have 3 dimensions, length, width, and height. That's why we'll have cubic units. Cubic inches, for example, inches of length, inches of width, and inches of height.
Okay.
Okay, questions, comments, concerns?
No.
All right. Test corrections, let's say for Friday.
We were doing yesterday.
Test corrections Friday, please. No written homework. Tomorrow for the test, you can start as soon as you get here from 8:30 onwards. I'll have them ready for you. If you want to have time, come early. You can have it until 9:30. Bye. Like, subscribe, and save. Don't forget. I think it'll work.